Hello and welcome to Physics Tips for Cambridge Students YouTube channel. Today we are going to be looking at the 9702 A-Level Physics syllabus and the topic of magnetic fields. This is the part 1 video of 5 videos that I'm going to make. And in this one, we are going to be covering concepts of a magnetic field. The second video covers force on a current carrying conductor. The third one, force on a moving charge. And the fourth one, magnetic fields due to currents. Then finally, the fifth one, electromagnetic induction. Now, electromagnetic induction used to be a topic on its own, but in this new syllabus, it has been incorporated under magnetic fields. Now, remember to subscribe to the Physics Tips for Cambridge Students YouTube channel. Hit the bell notification so that you get alerted of my future videos. And without much further ado, let's get started. Now, concepts of a magnetic field. That is the first video here. Now, a magnetic field is produced whenever charged particles do move. That is by an electric current. A moving electric charge creates an electric field and a magnetic field. So a stationary charge would tend to have only an electric field around it, but then a moving charge will have both the electric field and a magnetic field. Static electric charges only create electric field. Now, sources of magnetic fields are moving charges that we've just talked about and permanent magnets. Also, we have current carrying conductors, so having a magnetic field around it because they do have moving charges in them. Now, in permanent magnets, i.e. bar magnets, electrons spinning around the nucleus of each atom create a tiny magnetic field so that each atom acts as a tiny magnet. Now, the tiny atomic magnets line up with each other to produce a strong magnetic field with north and south poles at the ends of the material. Now, we call these domains. There is the magnetic field that being represented by the lines that you see. These are imaginary lines that are coming from a north pole into a south pole as shown. This was covered earlier in the 0625 syllabus. Now, as you can see, where the field lines appear to concentrate, that's where the magnetic field is strongest. And then where they tend to separate away from each other, that is a weak field. Now, the field around the bar magnet is non-uniform, so its strength and direction varies from place to place. Field lines show the path that a north pole would take, that is coming from away from a north pole because it gets repelled by a north pole, and into a south pole because it's a north pole attracted to a south pole. The direction of the field is taken as the direction of the force acting on a north pole placed in the field. Now, the field of a solenoid is due to the electric field. So this is a solenoid. A solenoid is just any coil that is carrying a current. So as you can see, the current enters from the right-hand side and then it curls according to the coils of the solenoid itself. And a magnetic field will be formed, and it is shown like that. Now, the magnetic field pattern is just exactly the same as the pattern of magnetic field in a bar magnet here. So North Pole would show right here, and then South Pole on the other end, as you can see there. Now, the right-hand grep roll gives the direction of the field for a straight conductor. So the thumb points in the direction of the current, and then the fingers curl in the direction of the field is shown there. So this shows the clockwise magnetic field, and then the current is being shown by the thumb. Now, we can use iron filing to magnify these field lines that we're talking about. This does not tell you the direction, but you can just see the pattern of the field. So for a solenoid carrying a current, the fingers point in the direction of the current and the thumb points in the direction of the field. So it's shown like that. We are going to look at the formulas later regarding this. So remember to subscribe to the Physics Tips for Cambridge Students YouTube channel and hit the bell notification. Please like, share, and comment. Signing out.